Hi guys. If you're watching this stream, thank you for watching and welcome back. And I know this kind of sucks, the face tracking thing, but this is the only way to keep my face centered because I'll be going here like this. I'll be sitting back like this, and the camera angles are not right when I watch this stream. So I hope this works fine. Let me just turn this off. See if this is okay. Okay. This is how I will look. I think this is fine. Yeah, this okay. Okay, fine. Let's go. We don't need face tracking. Can you just edit this? Wait, I'm editing this. So please do it. Is transform. Edit transform. 500. Okay. Now this works. While I've been this under, we'll start this. You're already live. Play this. Finally start. This was a program that we were doing yesterday, and I have no idea how this works. Today our task is figure this out, how this works, and finish. So what is the stream about today? Let's define that and stop just rushing into it, right? So our task, our main agenda of this stream is to finish at least two exercises from this chapter. We only have one exercise, not exercise. Exercise. One exercise, and we'll finish increment operators 2.8. Currently in 2.7, we'll finish 2.8 and its exercises. And if we have time, we'll finish 2.9, so 2.10, 2.11, 2.12. Yeah, I think we can finish the whole second chapter. Let me turn on the fan. I did something cool yesterday. I just cleaned my room. So I feel really better. If you don't clean your room, if you have ADHD, all those things are inside your head, and it's like your RAM. There's this concept of RAM in your head. Forgot what they call it. It's a cognitive load. That's what they call it. It's basically like the RAM. Computer science is deeply rooted with our daily lives, but whatever, your mental RAM or your, let's just say it's RAM. Your RAM will get fully filled with these things that your room is messy, and you have this thing to do with the evening, and all of those things will be in your mind. So just write it down somewhere. If it's cleaning your room or doing laundry, just go do that. Helps you focus better. Fine. No rant today. We just get into programming. I'll see. I'll see what we are getting. Nothing. No, let's debug this. Int main char as is as is as is a character array, and S is just an array. You don't want to call it character. S is just an array, and it has a limit of 100. S has 100. What we say columns? S has 100 columns. And C is supposed to be 0. Let's just initialize C. C is equal to 0 and I is equal to 0. We don't need I by the way, but fine. I just woke up by the way. While C is equal to get char. C is used to get our char. Uh, C is assigned to get char. And we're getting a character. And if it's not EF, the void loop continues and we'll keep getting the characters. And int x is equal to 0. Fine. It's just initializing x. And fc is equal to slash n char s of x. What does s of x do? Let's go to x carry. X carry drop. Delete this out to enable canvas background. Is there a need to change the canvas background? Let's go for okay, let's go. So this is our code. It's ugly, but it works. Right. This is our main function in ADI. Sorry, in main, and I'll let's write this down. We're initializing this character array of s. And, its limit is 100. Let's just say it has 100 as its limit. Control D. Let's just say that we have 100. This is 100. Just imagine this is. I know this is crappy, but fine. Whatever. This is 1, and it's 0. It's not 1. Array starts from 0, not 1. Fine. 0 to 100 we have. This is, even though this is not 100, just imagine. And so we initialize this. This is called S. There was a better thing to do this. Okay, fine. This is called S, and that's that. Initializing it inside of C. C is equal to 0, and C is equal to 0, and I is equal to 0. We don't need to write that. We know that. While C get char, EOF int x is equal to 0. Fine. And okay, fine. Nobody cares. F F this is true. F this is not true. F this piece of code is not true. Then it comes here, and what does it do? And it comes here. It does nothing. It just takes s of x. X is currently 0, right? Fine. We'll just write it down. X is currently 0. Just write it down. X is currently 0, and C. Let's just say that we are input our input as uh, let's just say it's he. Let's just say that it's we have two characters, right? How do you change this? Change this color. I don't think there's a way to change this. Whatever. It's he. So we have two characters. First character is H, second character is E. So when we do that, this code works. This code executes, right? This piece of code while loop works, gets inside the while loop, and we're getting the characters. Now we are inside the while loop, and we got this C. We have C as heads, right? If we input heads, it takes heads. And this piece of code works. This is what this is the piece of code that takes our character and put takes it and throws it inside a character array, right? Puts it inside our array, which is S. So we take H and we put it here at 0, right? Because X is 0, right here. It's mentioned here. X is 0. So X is 0. Fine. We know what X is. Let's write X is 0. If X is 0, then we are doing this S of 0 equal to S of 0 equal to H. We are saying this. Right. S of 0 equal to H. And this is the piece of code that we are writing here. And it works fine. And then it comes it goes back after this execution. It goes to the while loop and see if C is equal to get char and not equal to EOF. EOF means this /n. Oh, fine. End of file. So okay, fine. So EOF means it's basically control C. Fine. So it's not this. Just forget this. Just delete this. Okay. Then we do this again. By the way, this becomes 1 because of this piece of code. This because this plus x, it will take x first value of x, which is 0, and this will do every operation, and then assign, then actually add 1 to the x. So if we add 0 plus 1, it's basically 1. So we do this, right? And this is C. And my question is that currently we have two letters here, uh, H and E, right? When I do this, if C is equal to slash n, put char s of x. Right now, s of x is actually s of x. Yeah, s of x is actually x becomes 1 here, x becomes 2 here, right? So that's why this piece of code is not working, because s of x is empty. There's nothing inside s of x. If we do s of x minus 1, then we are accessing this. Then we are accessing head E. Let's see if it works. W and this should work. Still doesn't work. What's wrong? Zero 1. Let's just say s of x is equal to 1. And this works, but let's do something. First print x is currently 0. How is that x is 0? Okay, fine, fine. I understand. Like whenever this loop get executed, every time this loop get executed, right? After this point, it goes back, goes back to the while loop, and it starts from here, right? It starts by checking this, and then it comes back to this. Then x is 0. We can't. There's no way to x plus plus. The only thing it's gonna store is in 1, which is here, and that's why E is actually here. So let's write our thing here. X is equal to 0. At least we are learning about control flows now, so we don't have to leave it. Yeah, getting something. Now this works. plus x increment x to 6. Then value 6 is assigned to y. Okay, we are doing this wrong. Plus x is not how we should do things. Plus x is pre-increment. It's incrementing before we are assigning the value, and we don't want that. We want our value to be used and then later incremented. It's called post increment, and that's what we are doing here. If you can't see, sorry, that please skip that. Leave. And soon this see. Then now everything works. Do a slash in. And we'll do an x minus minus. Let us try the while loop here. X is not equal to 0. Escape one. Run it again. Minus x is not equal to 0. You do it like this. No confusion. Single x plus. Something else. Do I? Single y plus. Not getting an input y. We take cat y is equal to is of I. Do this. See if it works. It is not working. Why is that? X is equal to 8. You can clearly see that. x is equal to 8. So I have the permission to run. What if we do this instead of checking here? If you just make this an infinite loop, just break out of this loop. Is equal to, not we just print us a file. What if we do this? Update. You can do this before entering the loop. What if we, instead of doing x plus 1 here, what if we do x plus 1 up there? I'm tired of debugging. I'll just ask ChatGPT how things are, and then I'll come. I'll ask a lot of stuff. ChatGPT kind of sucks. Boundary condition connections means if I is less than or equal to x, so I less than x. What if it store more than 100 bits? Use 5. So let's just say that 5 into 10. 20 times. Take this. Just 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So just take this. There's no check-ins right and beyond that. This is what buffer overflow is. Ah, I see. You know what's happening? If you're wondering, like, what the fuck, we are just calling ETOI, and this is not working. We are getting hello good itself. We are getting the same exact word because put char takes a numerical input and goes through the ASCII character set and figures out what is the character equivalent of it and takes it and prints it. That's what put char is. It's in the name put char. But we don't want that. We need a integer. So we'll just do a printf. Printf percentage d and we'll use it. Everything is zero. Why? Because in the that is an important aspect of system state management data person looking at this code in a context of can define solutions. Expect a string that contains only digits at the beginning. Keeps converting character until it finds a non-digit. So it does not point to a digit. SFI does not point to a digit. It would need to be placed at a pointer where I is guaranteed to point to the start of the numeric string. Uh, Looking at the updated code from this architecture perspective, as of X is equal to 0 missing semicolon. Okay. I don't understand how ATOI works. Sticky character, right? And we'll just pass a whole character and stuff. Have no idea how to fix this. I understand what's happening. How should we do this? This is not how it's supposed to work. Just go to some standards. You're passing the whole thing. Don't need this. What's wrong with us now? Calling ATI, getting something back, getting zero. Why are we getting zero? It expects input string to start with a numeric digit optional. Continue until it's a non-digit characters. What's the point of the CTI function? Students 1, 2, 3. Oh, I see. The only FF. I understand. I thought of ETOI for something else. It should return a zero again. Do this. Should return us two. Did not return us two. Why? Should do this. Take the first two off. Won't work. Yeah. The program works exactly how it's supposed to work. But the thing is that what I thought the whole time I was programming the right thing. Even from the beginning, I was programming the right thing, but I didn't know. I thought ATI was something like it takes a character and it maps. It takes a character and it maps to its ASCII value like one or two or three or something, and it will just print it out. That's what I thought. It's completely stupid if you think about it. This function can't do those things with this few lines. We can't do those extreme ASCII thing with this full lines of code. I should have thought about it before, but I didn't. Forgot. Forgot. I don't know what I was thinking. Like, why would I do this? I was doing the right thing the whole time, even yesterday. I finished this thing like in the first like 20 minutes or something, because that's how easy it is. You know what? It's fine. At least we know that this works now. Get that. Get that. Comment down. This feels good. Finished 2.7. I don't think we need any like explanation on how ATI works now. And the AI, I've heard people say that like on YouTube, you're as a developer, you're fucked because AI is coming, and you see what AI is doing. Like, AI don't know what ATI. It could have told me that you know ATI just takes the first input and does something like that, but it didn't. It was just playing along my stupidity. I think the context matters a lot. I should have given more, proper prompt, but still, it's not there yet. AI will get there, but even only if AI can achieve AGI or what do you what is the full form of AGI? I just kept saying AGI, I forgot the full form. Artificial general intelligence, which can actually think for itself and which can actually make decisions. So what does ATI do? Uh, take a string as an input, take a string as an input, and goes through the string. If the string starts with a character, it immediately returns zero. If the string starts with a number, it returns you number, returns you the number. That's it. That's all. That's that's all the purpose of ATI and ATI, and that's what he's telling us right now. That's the thing. We'll read this in English. See how that's work. Char is just okay, fine. Do we know that? Gives numeric value of certain character and specify because of values 0 and 1, etc. from contiguous increasing sequence. Another example of char to int conversion is the function lower, which maps. Okay, right. This works for ASCII because corresponding uppercase. This is the function that we are supposed to. This is what I thought that it was doing, but in a different manner. But this is the kind of mechanism that I thought I was working with, but no, it's much simpler than this. Think what letters we do need to set. So we take small a and do that with the capital A. So if we take, just go to an ASCII, you know, we don't need that. This latter observation is not. If I see something like this, I get more curious to see if this actually truly exists or not. Then I go to ASCII table and I see it exists or not. Then I go down there and I see ASCII table as well written table. Then I will start figuring out where this ASCII table is stored in my computer and how does that work. And you get it, get deep down the rabbit hole, but you just have to know enough, just barely enough to keep moving. You don't need to know where the ASCII table is stored in the computer. You just don't. It's not required. But I still do that. I don't know why. Maybe it's just me, but fine. Is this because of the ADHD too? Not sure. Yeah, it's probably, novelty and stuff. Doctor told me. He warned me not to do anything else while doing this. He's rigid. We will use the C type dot h function from now on. There's one subtle point about conversion of characters to integers. The language does not specify whether variables of type char are signed or unsigned quantities. When a char is converted to an int, can it ever produce a negative integer? The answer varies from machine to machine, reflecting difference in architecture. This is what the meme is about, Uh, it works on my machine, kind of thing. On some machines, a char whose leftmost bit is 1 will be converted to a negative integer sign extension. Call it something the sign extension, not sign extension. It's not technically called sign extension. It's called something else. I forgot. Fine. It's the first digit. So I something. Sign of numbers. One common approach is to reserve a specific position in the array. Often the first element to indicate sign plus or minus. No, I don't know. I should do my research, but fine. Definition of C guarantees that any character in machine standard printing character set will never be negative. So these character will always be positive content and expressions. But arbitrary bit patterns stored in character variables may appear to be negative on some machines, yet positive on others. For portability specific signed or unsigned if non-character data has to be stored in variables. Relational expression like I greater than C. It's like chaining everything together. So it's the if C is a digit and 0 is not. However, functions like is digit may return any non-zero for value for true. And the test part of if while for etc. True just means non-zero, so this makes no difference. Implicit arithmetic conversions work much as expected. In general, if an operator like a plus or star that takes two operands, binary operator has operands of different types. The lower type is promoted to higher type before the operation proceeds. The result is of integer type. Implicit arithmetic conversions work as much as expected. In general, if an operator like plus or star, which basically means multiplication, takes two operands. Binary operator has operands of different types. The lower type is promoted to the higher type before the operation proceeds. So if the lower type means 23.00 into 4 What does it do? Just takes 23 into 4. It's just doing as same as this. It's 23.00 is the lower type, and 12 is the upper type, or 4 is the upper type. If we do this, it gives us the same answer, kind of. But all these things are ignored. Like if I give a float and to multiply it with a length. I think type conversion sounds awesome. Wait, let me learn more. Otherwise, I think I'll be seeing something stupid. Result of the integer type conversion. It states that conversion rules precisely if there are no unsigned operands. However, the following informational set of rules will suffice. Either operand is long double, convert the other to long double. Either operand is double, convert the other to double. If either operand is float, convert the other to float. Yeah, this is not what happens. This is not as same as doing this 23.00. This is not as same as this. Uh, the float is the bigger number here, so it will take the bigger one, keep it as it is, and it will convert our 4 into float, which is this. Yeah, this is what gives us the answers. This float is an expression not automatically converted to W. This is change from original definition. In general, mathematical functions like math dot as well use double precision. The main reason for using float is to save storage in large arrays, but less often to save time on machines where double precision arithmetic is particularly expensive. Okay. Conversion rules are more complicated when unsigned operands are involved. The problem is that comparison between signed and unsigned values are machine dependent because they depend on sizes of various integer types. For example, suppose that int is 16 bits and long is 32 bits. Fine. Then this is an int. So this basically is an int. It's not an int. Sorry, it's a long. -1 long, and -1 long is less than 1 u. What is an u? Unsigned integer. U is an unsigned integer. U means unsigned int. So okay, fine. So -1 long is less than 1 u. U means unsigned int is prompted to a signed long, but -1 l is greater than 1 ul, which is unsigned long. So unsigned long, and we have a long, basically -1 long, which is signed long, which is minus is the sign because -1 l is prompted to unsigned long and thus appears to be large positive numbers. Conversions, I think when we mix these things up, like unsigned long and long, and short, unsigned short, and just basically short, signed short, or something, and it gets more complex than we know. And I don't think we need to know these things, but anyways. Conversions take place across assignments. The value of the right side is converted to a type to the left, which is the type of result. A character is converted to an integer either by sign extension or not, as described above. Long integers are converted to shorter ones. Characters by dropping the excess higher order. bits. Thus, int I char c, int I is equal to c, c is equal to I. The value of c is unchanged. This is true whether or not sign extension is involved. Reversing the order of assignments might lose information. However, if x is float and I is int, then x is equal to I and I is equal to x. Both causes conversions. Float to int causes truncation of any factorial part. When a double is converted to float, whether the value is rounded or truncated is implementation dependent. I don't understand that. X is float and I is int, then x is equal to I and I is equal to x. Both cause conversions. Float to int and causes truncation of any fractional part. Fine, that I understand. If you try to assign a float value to an int, it basically becomes an int because that's how it's supposed to go. It's basically an int, and you're something, storing a float value inside an int. So it practically becomes int. It should be because you can't store float inside a container of int. It's different. Declared function arguments to be int. If you think about this tiny things about int and char and stuff, and the underlying implementation of these things, I think it's pretty cool for the time that these things were made. I think it was pretty awesome. I finally explicit type conversions can be forced. Cost in any expression with an unity operator called a cast in construction type name expression. The expression is converted to name type conversions, which is about the precise meaning of the cast is as if if the expressions was assigned to a variable of a specific type, which is then used in place. The whole construction, for example, the library routine SQRT expects a double argument and will produce nonsense if the inadvertently handle something else. SQRT is declared in math.h. So if n is an integer, we can use SQRT double n to convert a value n to double before passing it to scored SQRT double n. So we take this n, whatever n is, we convert it to double, which is this. This is how we do type conversion. See, converts it to double. So double SQRT double. Whatever the argument that we are getting back from SQRT is converted to double. Called root 2 is equal to SQRT. 2 crosses the integer 2 into double value to 2.0. 13 you need for cast. if our root 2 is int, and sqrt is giving us double, then automatically you converts to uh, what? Let's just write it down. Otherwise I'll forget. Security gives us double. Since we are signing the value when int will automatically typecast to where? Typecast to an int.